Alright, here's another simple parallel circuit. The only thing we're adding into it now is we got some prefixes in front of our units. So we got kilo ohms instead of ohms here. We're just going to need to pay a little bit more attention when we're plugging the values in to make sure we put them in correctly. So 10 kilo ohms, 2 kilo ohms, and 1 kilo ohm. So we're looking at 10,000 ohms, 2,000 ohms, and 1,000 ohms. Now to start off, let's just go ahead and plug in our values like normal. So for the total, we got 9 volts over here. So let's go ahead and put 9 volts in. And then for each resistor, we have a resistance value. So for R1, we got 10 kilo ohms. R2, 2 kilo ohms. And R3, 1 kilo ohm. Now we don't have, again, enough values to use ohms law on any individual resistor or on the total circuit. But if we go back to our formulas, we could use this one to find out the resistance total. And if we had the resistance total, we would be able to use Ohm's law to solve for the current. So let's go ahead and do that. Now what that's going to look like, let's write out the formula here so we make sure we put it into the calculator right, is this. So that's going to give us our resistance total. So if we go to plug those values in, see if we can bring up our calculator here. Let's go ahead and plug those in as we see. So we got 1 divided by, I'll put our parentheses in to make sure that we apply it to the entire fraction. So 1 divided by parentheses, 1 divided by 10,000 plus 1 divided by 2,000 plus 1 divided by 1,000. And then we can go ahead and end those parentheses. And our total is going to be 625 ohms. So 625 ohms. Now with that information, we can solve for the current here. So our total current will have that value next. So if we take 9 volts divided by 625 ohms, that gives us 0.0144. So again, we want to use our proper prefixes here. If we move this decimal over 3, that gives us 14.4 milliamps. So let's go ahead and write that in here, 14.4 milliamps. All right, now that we have our total, what can we do with the rest of these categories here? So in our series circuits, the current was the same across every resistor. But in parallel, it's the opposite. So our voltage, we're going to have 9 volts going here, 9 volts going here, and 9 volts going here. So everything's in parallel, but what we're going to have is individual current values going down each of these branches. So in our totals, we got 9 volts, which means across each resistor, only when they're hooked up in parallel, we have 9 volts across each resistor here. So all we had to do is carry that across. Now, to find the current values for each one, we have 2 pieces of information, so we can plug those into Ohm's law and easily pop out the current values. And then those current values should, based on our formula, add up to the total. So that's how we're going to go ahead and check our work. So we got 9 volts for resistor 1, 9 divided by 10,000 gives you 0.0009. So we could say, just to save a little bit of space here, that we have 0.9 milliamps. Or we could say that was 900 microamps. But we'll go ahead and just keep it simple for now. So the next one, resistor 2, we got 9 divided by 2000, which gives us 0.0045 amps. So if we move that over 3 spaces, that gives us 4.5 milliamps. And the last one, 9 volts divided by 1000 ohms, should give us 0.009. So 0.009 amps would be 9 milliamps, which we have half the resistance that we had in R2, so proportionally we have twice the current, which kind of makes sense, so we can kind of see what's going on as we move along there. And now with all these values, we should be able to add them up to check our work. So if we add 0.9 plus 4.5 plus 9 gives us 14.4 milliamps. So again, starting with the basics. Now we got all the tools we need to solve those. So if we look up here, we got 9 volts going down each branch. Now we can see what current was traveling down each one. Alright, so keep an eye out. We'll do a couple more of these. Help us along. Let me know if you got any questions. Email them or give me a call. Alright.